Welcome to today's class. Our topic is Avogadro's law. Avogadro states that equal volumes of all gases at the same temperature and pressure contain the same number of molecules. This is basically what Avogadro stated. It states that as far as the temperature and pressure are the same, that equal volume of all gases must contain the same number of molecules. So let's look at this question and see how it affects this. The question says, how many molecules are there in 4.0 moles of glucose? How many molecules? Now, I want us to know that Avogadro's constant is 6.02 times 10 raised to power 23. So, how many molecules are there in 4 moles of glucose? Now, for this particular question, or for this Avogadro's law, I will drop stoichiometry. I will drop my video on stoichiometry for you to watch, because the method I'm going to use now may be a little bit hard, but I use simpler methods in that of the stoichiometry. So the one I'm going to use now, here, it is going to apply Avogadro. But the one I use in the stoichiometry are the simple methods you can easily get your answers with. Okay, so the question says, how many molecules are there in 4 moles of glucose? So you say 1 mole of glucose will give you what? Will give you 6.02 times 10 raised to power 23 molecules. So 4 moles of glucose will now be 4 times 6.02 times 10 raised to power 23 divided by 1, and that will give us 24.02 times 10 raised to power 23. Leaving your answer in standard form, it will be 2.402 times 10 raised to power. You're going to subtract 1 since you moved backward. Whenever you move backward, you subtract 1. Times 10 raised to power what? 22 molecules. Answer. Now, Avogadro and Gay-Lussac, they have a lot of similarities in common. Let's look at another practice question. Okay, so let's look at this question. How many atoms are there in 4.0 gram of carbon? All right, so carbon, how do we solve? Carbon is 12, right? So 12 grams of carbon will give you, we are looking for number of atoms, will give you 6.02 times 10 raised to power 23 atoms. Therefore, 4 grams of carbon will give you 4 times 6.02 times 10 raised to power 23 divided by 12. Now let's solve this into this, 3, this into this, 2.01. So you have 2.01 times 10 raised to power 23 atoms. Answer. It's very simple, isn't it? Let's look at another question. Okay, so let's look at this practice question. How many fluoride ions are there in 1.46 mole of aluminum fluoride? Okay, so it's very simple. Let's solve. Now we know that 1 mole of aluminum fluoride will give us 6.02 times 10 raised to power 23 molecules. Now, why did I say molecules? You need to go and watch my video where I talked about elements, mixtures, and compounds. So, what is a molecule? Basically, a molecule has to do with combination of 2 or more elements. But when you are talking about atom, you just know that you're talking about one element. Okay, so 1 mole of this will give you this number of molecules. Therefore 1.46 mole of aluminum fluoride will give you 1.46 mole times 6.02 times 10 raised to power 23 divided by 1, and that will give us, so let's press our calculator. 1.46 times 6.02 times 10 raised to power 23. So that will give us 8.7892 times 10 raised to power 23 molecules. 23 molecules. Are we together? However, what you were asked in the question is how many fluoride ion? The question did not just ask you how many molecules are there in 1.46. The question said how many fluoride ions. Are we together? So we have gotten, what we got here is aluminium fluoride. So we are looking, right now we'll be looking at fluoride ion. Fluoride here has how many atoms? It has 3 atoms. So 3 atoms is equivalent to 3 ions. So all you need to do is to simply multiply it by the number of molecules we already gotten. And that will give us what? 2.64 times 10 raised to power 23 ions. Take note, what you are asked here is fluoride ion and not aluminium fluoride. Please take notes.